The job of a processor is to execute a set of instructions using data stored in memory to perform a particular task. What are instructions? Instructions are a segment of code containing steps that need to be executed by the processor. It can be divided into three parts: addressing mode, the opcode, and the operand. Addressing mode, we'll define it later. The opcode is the portion of an instruction that specifies the operation to be performed. The operand is the object on which the operations are performed. Say you give your system an instruction add 2 and 5. The values 2 and 5 are called operands. By definition, the object and quantity that is operated on is called operand. Here, add is the operator. The operator says what to do with the operands. So, how will the CPU get the operands to perform the operation? This is where addressing modes come in. The processor needs to be told how to get the operands for an instruction. We use addressing modes to tell the processor how to get operands for an instruction. Addressing modes is the method to specify the operand of an instruction. Addressing modes in a given instruction set architecture define how the machine language instructions in that architecture identify the operands of each instruction. It defines how the CPU gets values from registers and what needs to be done by the CPU in case the operands need to be specified from main memory. An addressing mode tells the processor how to get the memory address of an operand, whether the address is held in registers or is contained within a machine instruction in the form of constants or elsewhere. There are several types of addressing modes. We will look into them one by one. In immediate addressing mode, the data to be used as the operand is included in the instruction itself. That is, the operand is specified in the instruction itself. In this mode, the data is present in the address field. That is, the value of the operand is immediately accessed from the address field of the instruction. But there is a caveat. In immediate mode, the range of constants, that is the value of operands, are restricted by the size of the address field. An example for this mode would be an instruction to move the data 49B into AX register. Here, the operand 49B is specified in the instruction itself. Direct addressing mode. In this type of addressing mode, the memory address of the operand is directly specified in the instruction as a part of it. Here, the operand is stored in the memory address 5000. The CPU goes to the memory address 5000 and fetches the operand stored, that is 64. To recall, in immediate addressing mode, the value of the operand, say 49B, is specified in the instruction. In direct addressing mode, the address but not the value of the operand is specified in the instruction. In immediate addressing mode, operand's value is a constant as it is specified in the instruction itself. In direct addressing mode, the CPU goes to the address and finds the value of the operand. Since we know that values stored in a given address are variables that vary based on what is stored in memory at a given address at a given time, the operand of the immediate addressing mode will change according to the value stored in the address at the time of access. Register direct mode. In this mode, the data of the operand is stored in the register, that is, within the CPU. For example, add R1, R2. The address field of the instruction refers to a CPU register that contains the operand. To get the operand, there is no memory access involved. Register indirect mode. In this mode, the instruction specifies a register which has the address of operand. The operand itself is stored in memory and the instruction only specifies to the register, which in turn points to the memory location. Thus, the register contains the address of the operand rather than the operand itself.